Today we're looking at simplifying radicals. So simplifying radicals, for some of you, this is something you've seen before. If you've seen it before, you might have actually seen a technique where you take the number that's inside the radical and you factor it into its prime factorization. If you have any idea what I'm talking about and you remember how to do that, feel free to keep using that method. That's perfectly fine. But I'm going to be showing you a different method today, which oftentimes can be a little bit faster and it more closely fits the level of math that you're in. What we're going to do is we are going to look for the biggest perfect square that goes into 72. So, look at that list of perfect squares that you just made. So this is all the numbers on that x squared column. We're going to look to see what's the biggest one of those that I can divide evenly into 72. Well, the first number that's below 62 that's on that list is 64. 72 divided by 64. Is that a whole number? No. So 64 won't work. What about 49? The next one up.
Yes. No.
72 divided by 49. Is that a whole number? No. If you're not sure, you can check it in your calculator. I'll tell you right now, it's a no. Okay, what about the next one? 36. Can we do 72 divided by 36 and get a whole number?
Yes.
Yes? What is that whole number? 2. Okay. So then now I got something I can run with. The 5 that started out front stays out front. The root 72, I'm now going to break it up into two pieces. 72 equals 36 times 2, we decided. When we break it up into those two pieces, one of them must always be a perfect square. So this has to be a perfect square here. The other one, it almost surely will not be a perfect square. And that's expected. The reason why we want a perfect square is because I can actually simplify that square root now. What does the square root of 36 equal? 6. So then on my next line, I can change that root 36 into a 6. Now that 5 that was out front of the radical, it was multiplying it by 5. So I now have to do the 5 times the 6 to finish this off. 5 times 6, of course, is 30. So our final answer then is 30 root 2. Notice the root 2 stays a root 2 because it can't simplify any more than that. There's nothing smaller that we can pull out of the 2. No perfect squares we can pull out of it. So this is what we call simplified radical form, because we simplified the radical here. I'd now like you to practice that idea on these 4 problems. So for number 1, we look for the biggest perfect square that goes into 98. Well, this one you might see it pretty quick, because 98 divided by 2 is 49, which I know is a perfect square. So okay, 49 goes in. So, and 49 is in fact the biggest perfect square. So first step, I write it as root 49 times root 2, and then I simplify the root 49. Square root of 49 is 7, so it becomes 7 root 2 for the final answer. Yes, I do need you to write this line of work. If you skip writing this line of work, you actually start creating a habit for yourself that's going to cause you problems on certain types of problems. So we want to make sure to keep that there. So number 2 now. When doing number 2, we need to find the biggest perfect square that goes into 432. So I'm going to go over to my list of perfect squares. The biggest one we wrote down was 225, so I'll start with that. Can we do 432 divided by 225 and get a whole number? No. Okay, then I go to the next number up. 432 divided by 196. Decimal. Okay. 432 divided by 169. Decimal. Okay, 432 divided by 144. That one works. So, the 4 that was sitting out front of the square root stays out in front of our square root. And so I'm going to break up the 432 into 144 times 3. Because if I do 432 divided by 144, I get 3. Now I can go ahead and simplify that so it becomes 4 times 12 root 3, because the square root of 144 is 12. But then I still have that 4 times 12 sitting out front. I do need to do that multiplication. So 4 times 12 gives me 48. So our final answer is 48 root 3. Number 3 makes people angry. Because we can go through all of the perfect squares, and you'll find there is a perfect square that goes into it.
But
it's 4. The smallest perfect square that we actually care about. And so it becomes the square root of 4 times the square root of 210. Because that's 840 divided by 4. And so I can then take the square root of 4 equals 2, so that gives me 2 times the square root of 210. Now, you might be wondering, wait, but isn't there maybe a bigger number that goes into 210? In terms of perfect squares, remember it's got to be a perfect square that goes in, there's not any. You can even go through it systematically, 210 divided by 196, 169, 144, so on and so forth. There's no other perfect squares. That's as good as it gets. So that is our final answer. And speaking of as good as it gets, square root of 41, there's no perfect squares that go into 41 other than 1, but that one doesn't count here. Otherwise, we'd be spending the rest of our lives just dividing by 1. So since I can't divide out any other perfect squares out of 41, the simplified radical form is the square root of 41. So that's all we need to write there when it asks for a simplified radical form and it's already there. Right, we're now going to use that graph paper. Because coming out of last week's quiz, the biggest trouble area was problems like this. So we're going to go through how to do these. So first, above your first of 4 graphing grids, write down this equation. So to graph this, we need to first find the vertex. Now that's an important point there, because some people, when first seeing this problem, decide, okay, well, let's factor out the negative 5. Let's factor this as much as we can. And although this is factorable, it's not helpful to do so, because we're trying to graph it. And we don't need to factor in order to graph it. In order to graph it, we find the vertex using x equals negative b over 2a. We're going to use that formula. So if x equals negative b over 2a, let's plug in for this particular problem. We put the negative out front. B here is a negative 30. That is going to be over 2 times a. A is negative 5. So x equals a negative 30 over negative 10. So that's a negative, well, negative 30 divided by negative 10 is a positive 3. So notice x equals a negative 3. Yes, this part equal to a positive 3, but then it's negative because, remember, we had that negative out in front of the whole formula from the very start. So we now know that x equals negative 3. Once we know that x equals negative 3, what do? We plug it in. So let's plug that in. So we go y equals negative 5 times negative 3 squared minus 30 times negative 3 minus 40. So y equals, now remember when doing the negative 5 times negative 3 squared, I have to do the exponent first. So that's going to be negative 5 times a positive 9. Negative 3 squared, any number squared, is a positive. Then minus 30 times a negative 3. 30 times a negative 3 is a negative 90, so minus negative 90 is the same as plus 90. And then the minus 40 still hanging out there. Okay, so we get negative 45 plus 90 minus 40. Go ahead and do that addition going from left to right. Negative 45 plus 90 is 45. 45 minus 90 is 5. And so those are the coordinates of our vertex. Our vertex is going to be at negative 3, 5. So we put our first point at negative 3, 5. And then from there, are we going to be going up or down?
Down.
Down. Yep. And the reason why we know we're going down is because there's a negative in front of the x squared. And then also in front of the x squared, that's our vertical stretch. This one has a vertical stretch by a factor of 5. So instead of going over 1 and down 1 from our first point. We're going to go over 1 and down 5. So that's where our next point goes. Over 1, down 5, and go ahead and do that on both sides. Our next point, normally we go over 2, down 4. In this case, I'm going to go down 5 times that far, so it'll be over 2 and down 20. That doesn't fit. So since that doesn't fit, that means all I got to do now is just draw on the curve. So you draw on the curve, and one little note, remember when you draw that curve, the over 2 point was off our graphing grid. So down here, your curve should not be crossing that next graphing grid line, because the only time when we should cross it is way down off the bottom of the graph. All right, having done that one, let's do another one now. Go ahead and now do this one on your own. Go ahead and make the graph on your own paper, start to finish. So as you do this one, you should be finding that your vertex is at 5, -6. And so once you've done all the math and all the algebra to get that, first of all, check to make sure that you did it correctly. If you had any trouble, there's the work so you can see it. But then we need to go and plot that point. So clear off some room here since I'm having to do everything on the same piece. All right, so I go to 5, -6, put my first point. From there, am I going to be going up or down? Up. Yep, because it's a positive x squared term. But I'm not going to go over 1, up 1. Instead, I'm going to go over 1 and up 2. Yeah. Because we got a vertical stretch by a factor of 2 here. Whatever that number is in front of the x squared, that's our vertical stretch. And then normally I go over 2 and up 4. So in this case, I'm going to go over 2 and up 8. Because I'm multiplying the normal 4 by 2. Okay, over 3. Over 3 is normally up 9. 9 times 2 would be 18, so this would be over 9, or I'm sorry, over 3 and up 18, which is probably off your graphing grid if you went -10 to 10. Mine, I happen to be able to fit it up here at +12, so I'll go ahead and plot them. But if you couldn't, that's fine. Just go ahead and draw in your curve through those points from there. Graph number 3 for the day. Graph number 3 of 4. Again, go ahead and graph this one on your own paper. So there you can see what we get for our vertex. You hopefully got 1, 0 on it. That's the location of your vertex. Check the work if you didn't get that. See what happened. All right, so we put our point at the vertex, 1, 0. And then from there, are we going to be going up or down? Down, yep, because the negative 2x squared. And then when we go over 1, I'm going to go down 2. Because I got a vertical stretch by a factor of 2 here. So instead of down 1, we go down 2. And over 2 down 4 becomes over 2 and down 8. Because again, I'm multiplying however far you go up or down. by 2 in this problem. And then that's all that's going to fit on this particular graphing grid. So go ahead and draw your curve through those points, and you're done. Now go ahead and graph this one last problem. Now the part that makes this seem so much tougher is that 1/2 in front of x squared. We see that fraction and it kind of scares people a little. But actually it's not too bad. Because when we go and do that work, that 1/2 goes on the bottom. So we're multiplying it by 2. What is 2 times 1/2? 1. Half of 2 is just 1. So x equals a -2. And there's your x value that we're looking for. So now you got what you can plug in to find out what y is. And if you haven't done that yet, do that. And so you've hopefully found your vertex to be at -2, -9. And then it's going to be a matter of plotting that point and all the other points that go with it.
Is there not a clear board option?
Alright, so we plot the vertex, and then we start plotting all the other points. So over 1 is normally up 1. In this case, it's going to be over 1 and up 1/2. This one has a vertical compression by a factor of 1/2, so everything's only 1/2 as tall. So over 2 up 4 becomes over 2 and up 2. Again, 1/2 as tall. Over 3 is normally up 9, so over 3 will be up 4.5. Over 4 is normally up how far? 16. And 1/2 of 16 is 8, so it's over 4 and up 8. Alright, over 5 is normally up 25. So we go to 1/2 of 25, which is 12.5. So it's over 5 and up 12.5. Alright, well, it looks like we still got lots of room, so we got to keep going. We're going to plot every point we can. What about over 6? Over 6 is normally up 36, because 6 squared, of course, is 36. That's how we know. And 1/2 of 36 is 18. So we go over 6 and up 18. And it looks like that's going to be all of them that we can actually fit on there. So then draw the curve that goes through those points, and you're done with that graph. Last practice is going to be focused on factoring. Each of these 4 actually gets factored using a different method that you've learned. So part of what we're doing now is separating those techniques and knowing when to use each. So write down each, factor it best you can, and of course we'll work them through as you go here and there. Alright, so for that first one, this is going back to the very first type of factoring we did, where we would just look to see what can I factor out of every term. And what can we divide all of those terms by? 5. So that's what we're going to do. We take the 5 and we write it outside the parentheses. And then inside the parentheses is everything just divided by 5. So 15 divided by 5 is 3, so that's going to become 3x to the 6. Minus is still there. 35 divided by 5 is 7, so that's 7x to the 4th. plus is still there, and then 55 divided by 5 is 11. And then I can go ahead and double check here, look inside the parentheses. There's nothing else I can factor out of all three terms. And notice this is x to the 6. If this were x squared, we might keep going. But in this case, it's x to the 6, so there's nothing more we can do. So that means that one is done. That's as far as we can factor it. So when doing number 2 then, notice it's a quadratic. And so since it's a quadratic, that tells me I'm going to end up with the 2 sets of parentheses. And so I know they start with x's, and then I need to figure out what 2 numbers add to the middle number. So in this case, what adds to -1 and multiplies to -56. And so you think about different ways you can multiply to -56, approach it from that side first. And the one that jumps out to me is 8 and 7, because they are just 1 apart. So since they're just 1 apart, I know that will be my answer. The question is, which one's the positive and which one's the negative? Well, notice we're adding to a negative. That means I have to have more negatives than positives. And so our final factored form is x minus 8 times x plus 7. When you go and do the third one is basically a combination of the first and the second. So you're going to have to use both of those techniques in order to do the third. And then the fourth is what we did yesterday.
I think that's just it.
So the first thing we do on that third one is we factor out whatever we can out of every term. In this case, that's a 4. And then we take a look and see, can it be factored any further by looking inside? Well, there's nothing else I can divide out of every term, but it is a quadratic that I can factor. So I'm going to end up getting those 2 sets of parentheses. So inside the parentheses, what multiplies to 10 and adds to -11? Sometimes this can actually be tougher than it probably should be for us because we're so used to ignoring 1 as an option. There's your factored form. 4 times x minus 1 times x minus 10. And then finally, for that last one, it cannot be factored in terms of factoring out the 5 out of every term. In order to factor it, we're going to have to use the box method. Now, when setting up box method, remember the first term goes in the first box, and the last term goes in the last box. And then from there, notice one of the big easy things to see on this one is that it's 5x squared. The way I'm going to get 5x squared is going to end up being 5x times x. I can know that ahead of time, which makes my life a little bit easier. The question then is, what do the other numbers need to be? And seeing 21, my mind immediately leaps to 3 and 7. So I'm going to try 3 and 7 first. And I'm just going to guess which one goes where. So I'm going to guess the 3 and the 7 go that way. And see what I get. So that gives me 15x and 7x. And that looks very promising, because I need them to be 8 away. And they are. But notice it is a negative 21. So one of those has to be negative. In order for it to be a positive 8, the 7s have to be the negative. Having completed the picture, we can now write our factored form. It is x plus 3 times 5x minus 7. I get those numbers by reading across the top and down the left side on the outside of our square.